Welcome back. In the last few classes, we completed the most important parts of reflection: concave mirror ray diagrams, mirror formulas. Second type of spherical mirrors, convex mirror, and will revise the complete reflection chapter. Okay, let's start with some questions. Which mirror is used by dentists? So, dentist uses which mirrors means dentist always uses concave mirrors because they wanted a enlarged image. Which mirror is used as rear view mirror? Rear view mirror, it requires a wide field of view, which means convex mirrors are used. Write the magnification formula. M is equals to Hi by H naught or minus V by U. So this is the magnification formula for mirrors, right? For lenses, there will be little changes. Okay, let's start the session now. Let me introduce the another type of mirror, and this mirror we'll call it as a convex mirror. So coming to the convex mirror, a spherical mirror whose reflecting surface is curved outwards. If you observe this, it is curved outwards. Reflecting surface is curved outwards, and silver coating is at inwards. And a spherical mirror whose reflecting surface is curved outwards, that mirror is called as a convex mirror, right? And this mirror is also called diverging mirror. Which mirror? Diverging mirror. Why this mirror is called a diverging mirror? Because after striking, the rays comes and touches the mirror, right? After striking, what happens is the light ray gets diverges away, right? Okay, let me show you now. When a light ray comes and hits the reflecting surface, after this, the light ray gets diverges away. Hmm? For that purpose, this mirror is called as the diverging mirror. So let me introduce the points now one by one. Keep that in mind, very careful. So let's say this is the convex mirror. And that represents the silver coating. Now let's draw an imaginary line, and that line we'll call it as a principal axis. Same points related to the concave mirror. So this is principal axis. Here this point we'll call it as a pole. But for concave mirrors, we'll put focus and center of curvature towards this direction, right? But for diverging mirrors, like a convex mirror, we'll put the focus, center of curvature, those will be situated behind the mirror. In a convex mirror, focus and center of curvature are always behind the mirror. You need to remember these points, right? And remaining everything is same. Distance from pole to the focus is called distance between pole to the focus is called focal length, and distance between pole to the center of curvature is called radius of curvature. Everything will be same, but the points we have situated will be different. In a concave mirror, those will be situated in front of the mirror, but for convex mirror, these focus and center of curvature will be situated behind the mirror, right? Did you understand what I'm saying now? Okay. So now let's move on to the rules for drawing array diagrams. Rule number one here. Again, same kind of rules will be there, but those will be a little bit difficult. Let's draw. This is principal axis, and this is convex mirror. When a light ray passes parallel to the principal axis, let's say this is the focus. After reflection, what happens is it diverges away, right? So we have to make it extend it backward, and it looks like it touches it somewhere around here, and that point will consider as focus, right? So it looks like this ray, this reflected ray, which is this reflected ray, it looks like it is coming from the focus. It appears to come from focus. Sun, right? So this is the rule number one. When a light ray passes parallel to the principal axis, after reflection, it diverges and appears to come from focus. Appears to come from focus. This is the rule number one. Next, rule number two. Rule number two. Same kinds again. When a light ray, when a light ray, I'm sorry, wait a second. Okay, now when a light ray appears to come from focus, what happens is after reflection, it passes parallel to the principal axis, right? This is rule number two. When a light ray appears to come from focus, and after reflection, what happens? It after reflection, it diverges parallel to the principal axis, right? Okay, next, third situation, situation number three, center of curvature. Let's see what is going to happen now. So when a light ray comes and hits the surface like this, we have a focus here and we have a center of curvature here. When you extend it backward, it looks like it is coming from the center of curvature. The rays are not straight. Okay, a little bit bends. When a light ray appears to come from the focus, what happens is the light ray, after reflection, it diverges and appears to come. A ray directed towards the center of curvature is reflected back along the same path, which means a ray directed towards the center of curvature. It looks like it is coming from the center of curvature, right? So there is no reflection happens, right? So it reflected back along the same path. So this is rule number three. And final rule, that is nothing but when a light ray passes through the pole, in that situation, what happens is the light ray goes to the other medium without any reflection. Same kind, angle I is equals angle R. In this situation, angle I and angle R both are equal. At this situation, at this point, these obey laws of reflection, which means nothing but both angles are equal. But coming back to the remaining situations, it just depends on the bending of light, right? A ray striking the pole. Now let's see. Let's draw the lines now. Let's see the image formation by convex mirror. Image formation by convex mirrors. Let's start with the first situation, that is nothing but object at infinity. Infinity situation. Okay. See it carefully. Let's draw a line now. You have to be very careful while drawing these convex lens diagrams, convex mirror diagrams. Let's say this point is P, and this point is focus, and this point is center of curvature. Let's say the object is at infinity. Now the light rays are going to come parallel to the principal axis. Let's say two rays comes parallel to the principal axis. After reflection, they diverges away. Now we have to extend them backward. Let's extend them backward. It looks like these reflected rays, which are called reflected rays, these rays are called reflected rays, and these reflected rays appears to come from the focus, right? For that reason, right, which means the object, the rays haven't really met, but what happens is it looks like they appear to meet at one point over here, right? So we finally say the image is going to be formed exactly at the focus here. So let's see the position of the object is at infinity, position of the image at focus. But what about the size means? The size is highly diminished. Highly diminished. And coming to the nature, the rays haven't met directly, right? So we have to extend them backward to meet at one point. And those type of images we'll call it as a virtual and erect images have been formed. Virtual and erect images have been formed here, right? So did you get it? Now let's move on to the second situation now. So coming to the second situation, object at any position. So which means just like concave mirrors, you have to put the object at anywhere, but the same kind of image is formed. Let's say object is somewhere around here. Now object comes, light ray comes and hits the surface, and after that, what happens is there might be reflection happens. So this is rule number one. Now tell me what is going to happen now. The light ray after hitting it, you have to extend it backward. It looks like it hits the surface at focus. So let's consider one more situation. Let's draw a line now. And this ray looks like it is coming from the center of curvature. Let's extend it backward. Okay. I had taken an object very shorter, so it looks like it is little bit confusing. Right? But they haven't. But these two rays, while extending, they meet at one point over here, right? So we tend to find the image is going to be formed between pole and focus, right? Which means where is the position of the object? Position of the object is at any place, anywhere. Object at any position between infinity to pole, right? What about the position of the image? The image position is between P and F. What about the size of the image? Size is diminished. And what about the nature of the image? The image nature is virtual and erect. Why it is always virtual and erect means it forms only virtual and erect images because why? Because the rays haven't met. We have to extend them backward to make the image. Clear? Okay. So let's move on to the applications of these. Let's see the applications. So applications of these mirrors, which mirror these were? Convex mirrors. So coming to the applications, convex mirrors are used as rear view mirrors in vehicles because they allow drivers to see a large area of field behind the vehicle, right? Which means they have a capacity to provide wider field of view, and also they will provide upright image. The image will be as it is, and also more vehicles can be seen. More vehicles can be seen for that purpose, right? For that purpose, convex mirrors are used as rear view mirrors in vehicles, right? So, and also mm, vehicles like cars, buses, bikes, all these cases will use this convex mirror. So, coming to the next situation, they are also used in security mirrors, which will be situated security mirrors in shopping malls and many stores. And next important application is they are used in road safety mirrors. So they will provide used it sharp curves exactly where will be a sharp curve. They'll place this mirror so that both the persons can see which is coming, which vehicle is coming. And also in parking areas also these type of mirrors will be used, right? So that's it about it. So overall, the reflection concept has been completed, right? Right reflection, spherical mirrors, concave mirrors, converging mirror. Concave mirror is also called converging mirror, and concave mirror has a capacity to produce real and virtual images, and also it can provide magnified images. It can provide both the real and virtual images. It can provide the diminished and magnified images. Both will be provided, which means which mirror can be used for both the cases, which means if the object is away from the mirror, it can form mm, diminished and magnified images. When the object is very close to the mirror, it can form upright and virtual erect images. But coming to the convex mirrors, convex mirror is also called as the diverging mirror, and it can only form one type of images. Those images will be virtual images, and all the images will be diminished. And image that has been formed is always diminished, right? And also we discussed about the important mirror formulas. Mirror formula is 1 by f is equals 1 by v plus 1 by u. And coming to the magnification, m is equals to minus v by u. So those two formulas will be same. And also relation between focus and radius of curvature is r is equal to 2f, right? So let me show you the sign conventions for this. Let's say for a convex mirror, it is called pole, focus, and center of curvature. So p value, so first situation, focus, the light ray, incident ray might be towards this direction, and we are going to check the focus if you measure towards this direction, towards the direction of incident ray. So focus is always positive in convex mirror, and focus is negative in concave mirror. And let's say this is the object. If you measure the object distance towards opposite to the direction of incident ray, so we'll say u is always negative in both the cases. No need to worry about it because u is always negative. U is nothing but object distance. Coming to the image is going to be formed somewhere around here between pole and focus. The object is been situated around here, so we have to measure towards this direction. So v value is always positive. F is positive, V value positive, R value positive, everything is positive in these situations. F is positive. U, object distance is negative. Image distance is positive. Radius of curvature is positive. And coming to the final, height of the object and height of the image. Height of the object is above the principal axis, so it is positive. What about height of the image? It is also be positive because we got a virtual and direct images that to between P and F. So we got the image that has been above the principal axis, and height of the image and height of the object also positive. So let's compare these two for convex mirror. First concave and next for convex mirror. For convex mirror, U value is always negative. Here also U value is always negative. So coming to the V value is always negative. V value is always positive. So always negative for 5 cases. But final situation, we got a virtual and direct image, right? At that situation, it has been formed positive. And height, okay, let's see the focus. Focus is negative. Focus is positive. Radius of curvature is negative, and radius of curvature is positive. Right. Next comparison. Height of the object for concave here and convex here. For a concave mirror, height of the object is positive or negative? Positive or negative? It is positive, height of the object. Height of the object here also positive. But coming to the height of the image, it has been measured below the principal axis, it has been negative. But here height of the image is again positive, right? So you have to remember these values while doing the problems, right? We'll do the problems later. Okay. So let's see some one more questions today. So which mirror is called a diverging mirror? The mirror is nothing but a convex mirror, diverging mirror. What type of image is formed by convex mirror? It always forms virtual, erect, and diminished images. Virtual, erect, and diminished images will be formed on convex mirror. Where are focus and center of curvature located in convex mirror? In a convex mirror, focus center of curvature are located behind the mirror. What is the relation between R and F? R is equals to 2F. Many times I am repeating this question because this is the most important question. R is equal to 2F. Explain the images formed by convex mirror. A convex mirror always forms virtual, erect, and diminished image that always between pole and focus. The image always forms between pole and focus. That's it. Why are convex mirrors preferred as rear view mirrors? Because they provide a wider field of view and helps drivers to see more area behind the vehicle. Right? So that's it about the overall concept. And tomorrow onwards, we're going to start refraction concept. Which concept? Refraction. Okay, that's it. Thank you.